Alright, in section 4.3, we're going to be talking about multiplying and dividing rational expressions. So a lot of this is going to be playing off what we learned in section 4.1. So the first thing that we want to do is we're going to factor everything. Then we're going to see what we can cancel out. We're going to see what we can cancel out on top and bottom, but also see what we can cancel out diagonally, just like we reduce fractions when we're multiplying those together. So for example 1, we have x squared plus 7x plus 12 over x squared minus 6x plus 5 times x squared minus 25 over x squared plus 2x minus 3. So like we said, the first thing we want to do is factor everything. So if we have x squared plus 7x plus 12, if we factor that, that's going to be x plus 4 times x plus 3. When we factor x squared minus 6x plus 5, that's going to be x minus 5 and x minus 1. When we factor x squared minus 25, that's the difference of squares, so that's going to be x plus 5 and x minus 5. And then when we factor x squared plus 2x minus 3, that's going to be x plus 3 and x minus 1. Now that everything's factored, the next step is going to be to see what all we can factor out. So remember, we can factor out things that are on top and on bottom, but also factor out things that are diagonal. So let's factor out this x plus 3's. Let's see, we can also factor out the x minus 5 because we have one on bottom, one on top. And so now we're just going to multiply across top, multiply across the bottom, but we don't actually have to multiply out these binomials. So our answer is going to be x plus 4 times x plus 5 over x minus 1 times x minus 1. Now another way to rewrite this is x plus 4, x plus 5 over x minus 1 squared. Either one of these is correct. Alright, for our next example, we have a division problem. So we're still going to factor, but whenever we divide fractions, remember the first thing we need to do is keep, change, flip. So I'm actually going to combine that into two steps. For x squared plus 3x plus 2, that's going to be x plus 2 and x plus 1 over x minus 4 times x minus 3. Now remember, we're going to keep, change, flip, so that's going to make this our numerator, and that's going to be x minus 4 and x plus 1 over x minus 5 and x plus 2. So now that we have factored and we've done the keep, change, flip, we can see what all cancels out. Our x plus 2's are going to cancel out, and our x minus 4's will cancel out. That's going to leave us with x plus 1 times x plus 1 over x minus 3 times x minus 5. Now, just like in the last problem, we can rewrite that as x plus 1 squared if we want to, but this is our final answer. For our last example, we're going to look at what happens when we have a rational expression multiplied by just a binomial. So the first thing that we want to do, just like we typically do when we're dividing fractions, is we're going to put this over 1. Right? And then we're going to factor, and we have to remember to keep, change, flip. We have x squared minus x minus 20. That's going to give us x minus 5 and x plus 4. Right here we have x squared plus x minus 42. That's going to give us x plus 7 and x minus 6. And now we're going to keep, change, flip. So we're going to make this a multiplication, and we're going to flip the second one. That's going to be 1 over x minus 5. Keep that in parentheses. So now we just look and see what can cancel out. Our x minus 5's cancel out, and that's just going to give us x plus 4 over x plus 7 times x minus 6. And that's our final answer. Alright, this is all from section 4.3. Make sure you're doing your homework and work on your quizzes. Peace and love.